Hello and welcome back to the Algebra 2 series. Today we're looking at the prime factor method of factoring trinomials. And on the board here first we see a trinomial that most algebra students should be able to factor if we do this by what we consider the FOIL method. We would, in reverse, seeing the x's going first here, uh, we would first assess the number 3, and the nice part is the 3 is odd, and it's also prime. In this case, we could put a 3 and a 1 in there, and those are really our only possibilities. In order to obtain the 2 in the middle, we would have to make signs um, that are going to create a subtraction for that. And so we look at that first sign in front of the 3 to determine that we'll be subtracting the two numbers to make the 2. The second thing we look for is this minus here, which tells us that the larger of the two factors will have to be negative. So once again, this is a fairly routine factoring problem for Algebra 2 students, but that is the factorization there. Well, we learn little bits and pieces as we go along, but what happens when we get to a problem such as this one, where the numbers here are quite large and they have many factors? Notice that the 127 is not divisible by 3, and therefore we can't factor out a common term. Well, today I'd like to show you, this is actually a two-part series. I'd like to show you uh, a couple of ways and some techniques in order to handle something this difficult. The first thing I work with is the 18 and the 60, because those are the two numbers that will produce for us the 127 in the middle. And I prime factorize those numbers. 18 is a multiple here of several different values, but to actually break it down into primes, we would end up with 2 times 9 or 2 times 3 times 3. And 60 comes out to be 2 times 3 times 2 times 5. And that's because 60 is 6 times 10, but I want to bring this all the way down into primes. Now, before I finish this out, I'm actually going to reorder these guys. I like to put my prime factors in smallest to largest. I was just writing that so it would look nicer, but it's 2 times 2 times 3 times 5. Our first step in the technique of using the prime factor method is to try to attain a 127 by grouping these numbers, all of these primes. And we're going to group them in such a way that we produce two groups that are products, and then we will subtract, as we know, because of this sign here, we're going to try to subtract for 127. Well, I actually have a clue here, and that is the 127. The 127 is an odd number. And if I'm going to subtract two numbers to make an odd number, I can either subtract an even minus an odd, that will produce an odd, or I can subtract an odd minus an even, and that will produce an odd number. So if I'm going to generate a 127, then my two groups, the groups over in the bottom here, I'm going to have to make sure that all of my 2's are in the same grouping. In other words, I can't break them apart, because if I break them apart, my products will be even and even, and that would produce an even middle term. So just for fun, let's go ahead and see what would happen if we perhaps we went like something like this. Let's just break this apart into two somewhat balanced groups here. In the first case, this is 4 times 6, or 24, and in the second case, this is 15 times 3, or 45, or you could say 9 times 5, I suppose. Well, the problem with this is that if I subtract these two numbers, either way, I'm not going to get a 127. As a matter of fact, I'm going to get a number that's very small. So what I say about that is that my two blobs of numbers are too well balanced. They're too well balanced, and we don't want balanced in this case. We actually want unbalanced in order for us to attain the 127. So I'm going to back this all up, and I'm going to try to redo this with a more unbalanced grouping. For example, maybe I just put all the 2's together and then I put all the other numbers together in a separate grouping. Now that's much more unbalanced. In this case, this is an 8, and then this one would be 27 times 5, which would be 135. And if I subtract, I guess I'm going to have to subtract in this direction. I would end up with 127. So in 2 tries, I was able to get my 127 in the middle. So that's the first step, is to arrange your prime factors into numbers that can be grouped in such a way that we can get, in this case, by subtraction. Of course, if this sign way up here were positive, then we would add. But in this case, it is subtracted, and so we will subtract for that middle term. In this case, we now have 135, and we have the 8. And so I go back to the beginning here, and I inspect the 18. The 18 came from up here in the first term, and so the 18 will be broken up into a 2 and into a 9. 2 and 9. So I'll write here 2x and 9x. That's my factorization. The 60 was broken up into 4 and 15. Now I know the 4 and 15 go in there, but I don't know which one pairs with which one. And so this is the way I tend to do this. I take the 2x, which is over here, that gets paired with the last term, and then the 9x will get paired with the term just opposite it. So we see that since the 2 is paired with the 4, we'll end up with a 4 in this position here. The 9 is paired with the 15, and so the 15 will be placed here. And in order to attain the signs, we notice that the 9 times the 15 gave us the 135, and that should be a positive value in order to get the 127. So once again, 9 and 15 should be positive. So here's our 9, and then here's our 15, so that should be positive, and then the 2 times the 4 should be negative. So I've made a bit of a mess here, but as you can see, I have successfully factored a very difficult trinomial that you see there. In the next series, I will continue with a couple more examples that vary a little bit on this. There you go.